So we had the projection before, and we said we can do that projection, and we know that the cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v. But if I say that that means that cosine theta is going to equal 0, so then we have 0 equals u dot v over magnitude of u times the magnitude of v. Well, the only thing we really care about is that u dot v equals 0. So we don't even care about the magnitudes. So that's where we get this formula. If two vectors are orthogonal, the dot product is equal to 0. Okay? So I guess I have. So I have v equals 2i minus j and w equals 3i plus 6j. And I want to know if these are orthogonal. Orthogonal means perpendicular. So I say, well, the dot product, v dot w, is equal to 2 times 3 plus minus 1 times 6, which is 6 minus 6, which equals 0. So therefore, they're perpendicular because the dot product is equal to 0. Okay? All right, so now we have some work problems. Let's see what I have here. Let's see, it's 12 o'clock. Do we want to do another one of these projection problems? Does anybody want to do another projection problem? I know they're kind of long, maybe confusing. I'll be happy to do another one. You do? Okay. You want to do it with me, Delaney? Okay, we'll do our best, right? So we have here our axis. So we have v is 1 in the x direction and 3 in the y direction. So right there, that's vector v. All right? And w, let me make it a different color. W is 1, 1. So there's w. All right. So we want to decompose v into two vectors, v1 and v2, where v1 is parallel to w and v2 is orthogonal to w. Okay? So let's see. Here, let me so I want to make, so we have this new vector that's going to happen where this one is v2 and this one is v1, right? Down here. Come on, make it v1. All right. Do you have any ideas, Delaney? Do you want me to write the formula up on the board? I know you don't have it memorized yet. Okay. So we know that's a projection. And we're going to project v onto w. And that's equal to v dot w over the magnitude of W squared times vector W. Okay? And what's that going to give me? Which vector, Delaney? No, that's going to give me V1. Because the projection of V onto W is V1. Does that make sense? Okay, good. All right, so now let's see what we got. Let's put in some numbers here. What's V dot W? How do we find V dot W? Do you know? One times 1 plus 3 times 1. Good. So that's 4. How do I find the magnitude of W squared? One times 2. 1 squared, yes. 1 squared plus 1 squared, which is 2, right? So the magnitude of W is equal to that. Yes, exactly. Okay. And then times vector V, and we'll just do it like this, 1, 1, just for ease. Okay? Good so far? All right. So this is equal to 2 times this vector. So my new vector, or my V1 vector, is 2, 2. Very good. You got this. All right. Now, how do I find V2? Because 4 over 2 is 2. That's okay, no problem. Okay, so far so good? All right. So now how do I find V2? Yes, I do. And then what? I mean, if you don't know, it's okay. You can say, I don't know. Okay, that's fine. So here's vector V, and here's vector V1, and I basically want to find V2. Who can tell me how I can find it? Oh, you got it, Delaney? Yes, it's V minus V1. So we have V is equal to 1, 3, and V2 is equal to 2, 2. So minus 1, 1 is V2, right? Okay. So now I want to find out if V1 well, I mean, these are my answers, but let's just check and say are these angles, now if V1 is parallel to W and V2 is perpendicular to W, we can say that the cosine of U times V should equal what? What is U dot V? Remember, U dot V is the angle between them. What should that equal? What should U dot V equal? Do you know what I'm asking, Delaney? Okay, no problem. So, just to show that, we want to show that V1 is orthogonal to V2, right, or perpendicular. So the angle between them has to be 90 degrees, right? What's the cosine of 90 degrees? 0. So remember we said that U dot V has to equal 0. Well, we have V1, which is, so we want to know that 2, 2 dot minus 1, 1, that's equal to minus 2 plus 2, which equals 0. So check, they're orthogonal. Okay? That's pretty much all there is to it. Did that help, Delaney? Oh, sure, no problem. Thank you. Does anybody else have any questions?